Dear students, welcome to CR's digital classes. Today's concept is single correlation coefficient. So let us check it out how the correlation coefficient goes on. So here is a question version also we have. Write down the hypothesis and test statistics formula to test the single correlation coefficient. So here is a question version also. Let us check it out. Write down the hypothesis and test statistics formula to test the single correlation coefficient. So this is a question we have. Now let us go for the solution, how single correlation coefficient goes on, or a procedure we have here. So let x1 comma y1, x2 comma y2, so on up to xn comma yn be a bivariate random sample. So let us go for the procedure of this method. So let x1 comma y1, x2 comma y2, so on up to xn comma yn be a bivariate random sample of size n, small n, drawn from a bivariate normal population we considered here. So obviously for correlation we need a pair of data. So I'm considering here x1 y1, x1 set and y1 y set. So drawn from a normal population again with size n. So next, let smaller be the sample correlation coefficient. So here definitely we require population and sample correlations, right? So smaller I am considering as sample correlation and rho as population correlation coefficient. So both I have considered. Now let us check it out how the null and alternate hypothesis goes on, and then test statistics also let us deal. So under null hypothesis I am considering H naught as rho is equal to 0. So we know whenever rho is equal to 0, that is rank or correlation goes to 0, then two variables are uncorrelated, right? So same here I am considering two variables are uncorrelated under null hypothesis. Now let us check it out alternate hypothesis. Under alternate hypothesis H1, rho not equal to 0 I am considering. Yes, null hypothesis whenever you consider equal to, here in alternative we will consider not equal to. So rho not equal to 0 we considered here. That is two variables are correlated. So obviously they are uncorrelated we have considered, here it will be correlated. So that is about null and alternative hypothesis. Now let us go for test statistics formula for correlation. So here is formula we have. T is equal to r minus rho by root over 1 minus r square by n minus 2 is the formula for us. Now for this formula again we have assumed under null hypothesis as rho is equal to 0, right? So let us make that changes to the formula, that is wherever rho is equal to rho we have, make it as 0, and let us rewrite the test statistics formula for us. So under H naught we have rho is equal to 0. For that what I am doing is this minus rho I am taking as 0. So minus rho will go off. Simply remain with r by, and again I am splitting this formula to make it easier. Numerator and denominator I am splitting separately, and I am writing in this way, r by root 1 minus r square. Only numerator I have wrote as root 1 minus r square here, and then I have done the reciprocals to the formula, and I have wrote into root 1 n minus 2 upside. So the same formula, no confusion at all. Whichever comfortable you are, go with it. Only thing is that rho we have removed, rho we made it to 0. That's all. So the same formula, just know what we have learned. So follows T with n minus 2 degrees of freedom. So yes, it's a T test, and whenever small samples we have, we'll have a degrees of freedom also. So here degrees of freedom goes as n minus 2. So that we represent here. So now let us go for the decision, how the decision will take. So if calculated value of mod T is greater or equal to table value with n minus 1 degrees of freedom at 5% level. So here table value again as all the small sample test, how we will consider in the same way we have to consider here. So degrees of freedom and LOS together we'll consider. So if at all it is 5% LOS and degrees of freedom, so n minus 2 degrees of freedom we have to consider. So with that degrees of freedom and critical LOS will decide a critical value, that is stable value from T tables will obtain. So that we'll consider, and we'll take our calculated value T calculated and we'll compare it. If at all the calculated value is greater than table value, we have to reject null hypothesis, otherwise otherwise we have to accept null hypothesis, the as usual decision which will take for all small samples, right? So the same thing, mod t, if at all mod t is nothing but calculated value, so calculated value is greater than or equal to table value, then reject h naught, otherwise accept h naught. So then reject a hypothesis, that is your null hypothesis h naught. So this is the how the decisions we take for the t-test. So this is a procedure of t-test for correlation, single correlation coefficient. So whenever we have single correlation in the sense one sample correlation, one population correlation in the problem. So we go for this procedure, we use this test statistics, and we'll obtain the conclusions for that particular data. So hope you have understood this test for correlation coefficient. See you all in the next session. Thank you.